The trailing edge flaps and leading edge slats are high-lift devices that change the aerodynamic configuration of the airplane to increase lift and decrease the stall speed during takeoff, approach, and landing. Both flaps and slats are normally extended and retracted through the operation of separate power drive units. The drive units are powered by the center hydraulic system. If the center hydraulic system pressure is not available, then an alternate system using electrical motors can operate the power drive units. The alternate system is described later. A flap position indicator located to the left of the landing gear lever contains a left and right pointer for the left and right flaps and the left and right slats. The right pointer is normally hidden behind the left pointer. Notice that the maximum flap extension speeds are placarded around the flap position indicator. The flaps have 7 positions: up, 1, 5, 15, 20, 25, and 30. Flaps 5 and 20 are takeoff flap positions, with 5 being the most common for takeoff flaps. Flaps 25 and 30 are the normal landing flap positions. Flaps 20 is used for landing with non-normal operation. The slats have 3 positions: up, takeoff, and landing. Both flaps and slats are moved using a single lever. With the lever in the 0 detent, all flaps and slats are in the retracted position, and the flap indicator pointer indicates up. With selection of the flaps 1 position, the flaps remain up and the slats move to the takeoff or mid-range position. The slats remain in this takeoff position with flaps selected to 5, 15, and 20. Selection of flaps more than one will cause the trailing edge flaps to actually extend as selected. You may notice that the inboard ailerons will droop when the flaps begin to extend. Beyond flaps 1, the flap position indicator indicates trailing edge position. The slats remain in the takeoff position up through flaps 20. Selection of flaps 25 or more will cause the slats to extend to the landing position. Flaps lever gates are installed at flaps 1 and at flaps 20. The flaps 20 gate prevents inadvertent retraction of the flaps past the go-around gate, while the flaps 1 gate prevents inadvertent retraction of the slats. B767 flap maneuvering speeds allow for a normal 25-degree bank for maneuvering, plus an additional safety factor of 15 degrees before buffet onset is encountered. Flap maneuvering speeds are normally set as bugs for takeoff and landing. The maneuvering speeds are based on flaps 30 VREF as follows: flaps 0, VREF plus 80 knots; flaps 1, VREF plus 60 knots; flaps 5, VREF plus 40 knots; flaps 15 or 20, VREF plus 20 knots. The flap load relief system is designed to protect the flaps from excessive air loads. With the flaps at 25 or 30, the flap load relief system is armed. If the airspeed exceeds the selected flap's airspeed limit, the flaps automatically retract to 20. When the airspeed is reduced below the limit, the flaps return to the selected position. There are no indications of the operation of flap load relief other than the observation of the flap position indicators displaying less than the selected flap settings. Flap and slat non-normal operation. Alternate flap operation. Normally, the flaps and slats are extended or retracted through their power drive units, PDUs, that use hydraulic power. The same drive units may also be operated using electrical motors. Generally, alternate flaps are used only when center hydraulic system pressure is not available. Alternate flap extension takes about 4 times longer than normal flap extension, or about 2 minutes to extend from flaps up to flaps 20. The alternate flap system incorporates 2 alternate flap switches and an alternate flap selector. There is 1 alternate flap switch for the leading edge slat drive system and 1 for the trailing edge flap system. When pushed to alternate, each switch does the following: disables and depressurizes normal hydraulic control for the respective slats or flaps, arms the respective slat or flap electric motor. With alternate selected, the alternate flap selector can be used to extend, retract the flaps or the slats or both together through the electric motors. Rotating the alternate flap selector signals the electric motors to electrically drive the flaps and slats to the selected position. According to procedures, the alternate flaps are not selected beyond 20 because flap retraction from 30 to 20 in case of a go-around would take too long. Therefore, the alternate flap positions of 25 and 30 are not used. During alternate flap operation, the following operational modes apply. Flap asymmetry and flap load relief protection is not provided during alternate flap operation. Slat asymmetry protection is functional. Leading edge slat disagreement. A leading edge slat disagreement will cause the leading edge light above the flap position indicator to illuminate and an ICAS caution message of leading edge slat disagree to be displayed. The light and alert message indicate that the slats are not driving toward their commanded position. In this situation, the hydraulic power to both slats and flaps is automatically shut off. Leading edge asymmetry. The indications and actions for leading edge asymmetry are identical to the slat disagreement situation, except that the ICAS message is leading edge slat asym. In this situation, the hydraulic power to only the slats is shut off. This situation inhibits any slat operation by the alternate system. Trailing edge flaps disagreement. When there is a trailing edge flap disagreement, the trailing edge light illuminates, and ICAS displays the caution message of trailing edge flap disagree. The caution is displayed because the flaps are not driving to their selected position. In this situation, the hydraulic power to both slats and flaps is automatically shut off. The trailing edge light and ICAS message may also come on because the flap lever is not positioned properly in any detent. The hydraulically powered flaps and slats will stop operating in this situation, but the condition is easily corrected by moving the lever into the desired detent. Therefore, if the pilot inadvertently leaves the flap lever out of a detent, the flaps and slats will appear to have locked out. Correct operation of the lever will keep this from happening. Trailing edge flap asymmetry. With a trailing edge flap asymmetry, the action of the system is identical to the disagreement failure. The trailing edge light illuminates. ICAS displays a caution message of trailing edge flap asym, and hydraulic power to both slats and flaps is shut off. Flap load relief inoperative. Inoperative flap load relief also causes the trailing edge light to come on and the ICAS advisory message of flap load relief. These messages are displayed only when the system is not functioning as designed. In other words, the flaps are not retracting when the airspeed exceeds the flap limit speed. Hydraulic-driven generator. In a situation where the hydraulic-driven generator is the only remaining generator electrical power source, hydraulic power for continued hydraulic-driven generator operation is primary. Therefore, hydraulic flow to the slats and flaps is reduced, resulting in increased slat and flap operation time. The 767 has 6 flight control switches on the accessory panel. There are 3 wing switches and 3 tail switches.